Welcome to episode 41. Why is structured output so hard? Have you ever asked ChatGPT for a nice, clean JSON output only to get something extra? You know, the little bits of commentary like, sure, here's the JSON you requested, or a trailing sentence explaining the code. It's a common headache for developers. You just want the data, but the model insists on having a conversation. Why is getting clean, structured output from these powerful generative models so difficult? Today, we're diving deep into this challenge. We'll explore why these models struggle to stick to the rules and look at some smarter ways to get the precise machine-readable formats we need. To understand this problem, let's use a logistics metaphor. Imagine you're running a shipping company. The natural output of a generative model is like loose cargo. It's a jumble of items of all shapes and sizes, packed however they fit. This represents the free-flowing creative text that models like ChatGPT are great at producing. It's flexible, expressive, and can go in any direction. Now, what we often want as developers is a standard container. Think of a JSON object. It has a rigid structure, specific dimensions, and strict rules about what can go inside and how it must be arranged. This is our desired structured output. It's predictable, machine-readable, and essential for building reliable applications. The rules of that structure, like correct syntax, curly braces, and commas, are the format constraints. They define the exact shape of the container. When we ask a model to produce JSON, we're essentially asking it to take all that loose, free-form cargo and perfectly pack it into one of these standard containers. And when the model fails, maybe by adding extra text or getting the syntax wrong, that's like the container breaking. The cargo spills out, and the whole system grinds to a halt because the output format is invalid. So, what's at the core of this issue? It boils down to the fundamental nature of generative models. These models are, by design, incredibly creative text predictors. Their entire training process is about learning the patterns of human language and generating the most probable next word in a sequence. Think of them as expert storytellers or conversationalists. Their strength lies in continuation, expansion, and generating novel, free-form text. They are built for creative freedom, not for rigid adherence to rules. When we impose a strict format like JSON, we are creating a direct conflict with this natural tendency. We're telling a free-spirited artist to paint by numbers, and only by numbers. The model's instinct is to complete a thought, to add context, or to be helpful in a conversational way. For example, when it adds, "Here's your JSON," it's doing what it's been trained to do, engage in helpful dialogue. It doesn't inherently understand that this helpful text breaks the parser that's waiting for the data. This is why models often break the container. The more rigid and complex your desired format, the more you are fighting against the model's core function. It's a paradox. The very flexibility that makes these models so powerful is also what makes them struggle with strict constraints. They are trying to fit their vast probabilistic understanding of language into a tiny, unyielding box. Sometimes the pressure is too much and the box breaks. This leads us to how most of us try to solve this problem today. If you've spent any time working with LM APs, you're probably familiar with the begging approach. We write prompts like, "Please, please, please, only output JSON. Do not include any other text." No explanations. Just the JSON. We try to add negative constraints, saying, "Do not do this," and "do not do that." We might even show it a few examples and hope for the best. This is what I call prompt engineering by begging. We're essentially pleading with the model to behave and suppress its natural instincts. And while it can work sometimes, it's incredibly brittle. A slight change in the model's version, a different input, or just a random fluctuation in the output generation can cause it to fail. It's not a reliable or scalable solution for production systems. You're constantly at the mercy of the model's mood, and your application's stability hangs by a thread. We're treating the model like a black box and just hoping our magic words are persuasive enough. But there has to be a better way than just begging. So, what are the more robust solutions? How do we move beyond begging and start engineering reliable, structured output? The key is to shift from influencing the model's behavior with words to imposing actual constraints on its output generation process. Let's look at a few powerful techniques. First up is a method called constrained decoding. Instead of letting the model freely choose any word from its vocabulary at each step, we programmatically restrict its choices. For example, if we're generating JSON and the model has just produced an opening curly brace, we know the next token must be either a closing brace or a double quote to start a key. We can force the model to only consider valid tokens at that specific point in the structure. It's like putting guardrails on the generation process, making it impossible for the model to go off track and produce invalid syntax. It's no longer a suggestion, it's a hard rule. Another powerful technique involves using grammars. You can define the exact structure of your desired output using a formal grammar, like a context-free grammar. This grammar serves as a blueprint for the output. The generation process is then guided by this blueprint, ensuring that every single token generated conforms to the rules you've set. Think of it as giving the model a precise architectural plan instead of just a vague description of the house you want. Libraries like Microsoft's TypeChat or the Outlines library are fantastic examples of this approach. They allow you to define your output structure using something as simple as a TypeScript type or a pedantic model, and they handle the complex task of guiding the model to produce a perfectly matching output. Finally, there's the function calling or tool use feature that has become popular in models from OpenAI, Google, and others. This is a highly specialized form of constrained output. You define a set of functions with specific parameters and their types. When you make a request, the model can choose to call one of these functions by generating a JSON object that matches the function signature. This is a huge step up because the model provider has done the hard work of fine-tuning the model to be exceptionally good at producing the specific JSON format. It's been trained to recognize when a tool is needed and how to generate the correct arguments. It's a much more reliable and integrated way to get structured data as it aligns with the model's training rather than fighting against it. Let's recap what we've covered. We started with the common frustration of LLMs adding extra unwanted text to our structured data requests. We used the loose cargo versus standard container metaphor to visualize the conflict between the model's free-form nature and our need for rigid formats like JSON. The core problem is that these models are designed for creative text generation, and strict constraints go against their very nature. We then saw why simply begging the model in the prompt is a brittle and unreliable strategy. It's like hoping for the best instead of engineering for success. The real solution lies in moving towards more robust methods that impose hard constraints on the output. We explored constrained decoding, which limits the model's choices to only valid tokens at each step. We talked about using formal grammars to provide a precise blueprint for the output, with tools like TypeChat and Outlines leading the way. And finally, we looked at the power of function calling, a specialized feature where models are fine-tuned to generate structured JSON for specific tools. By understanding the nature of these models and using the right techniques, we can move from fighting against their generative freedom to guiding it effectively. We can build applications that get reliable, perfectly formatted data every single time, without the need for begging or retries. It's about working smarter, not just prompting harder. Thank you so much for joining me for this deep dive into structured output. I hope this gives you a clearer understanding of the challenge and some powerful new tools to solve it. If you found this helpful, please hit that like button and be sure to subscribe for more content on building with large language models. Let me know in the comments what your biggest struggles with structured output have been. See you in the next one.